MS Ramaya University of Applied Sciences.
Hello students, in this video we will be discussing the manual part program method for computer numerical control CNC machines. The learning objective of machine shop simulation through CADEM software are to provide experience on manual part programming for CNC turning, milling and drilling machines, to identify the sequence of operations performed on machining center, to select the cutting tools, work holding devices and cutting parameters for various machining operations, demonstrate the different types of operations on CNC turning and milling machines. Computer numerical controlled CNC machine is a microprocessor-based system to store and process the data for the control of sliding motions and auxiliary functions of machine tools. In the early 1959s, MIT announces Automatic Program Tools APT programming language. Later stage 1970s, CNC machine tools and distributed numerical control are started. 1980s, graphics-based CAM systems are introduced. There are two types of machines used in the manufacturing industries. Machine tool applications: turning, milling, drilling, grinding and other metal works. Non-machine tool applications like assembly, inspection, etc. Applications of CNC machines. Generally, CNC machines are used in batch and high volume production, repeat and repetitive order, complex part geometries, many separate operations on one part. Advantages and disadvantages of CNC machines. There are many advantages like high flexibility, easier programming and editing, high accuracy and repeatability, reduced inspection, ease of interchangeability, less scrap and rework, reduced non-productive time, consistent quality, less material handling, less floor space, flexibility in design changes, reduced manpower. Disadvantages of CNC: higher investment cost, higher maintenance cost, finding and/or training NC personnel. Classifications of CNC machines. The CNC machines are classified according based on the motion type, point-to-point, straight and contouring systems, based on positioning system, incremental or absolute method, based on control loops, open loop and closed loop system, based on number of axes, 2, 3, 4 and 5 axis CNC machines, based on power supply, pneumatic, hydraulic and electrical. Motion control in CNC machines. There are two types of controls. One is point-to-point control and other one is straight and contouring systems. See the figure, point-to-point control and straight and contouring systems. Coordinate system. 2D, XY, XZ and YZ axis and 3D, XYZ axis coordinates are using in CNC machines. It is based on application and type of machine. Positioning method. There are two positioning methods, namely absolute method and incremental method. Absolute dimension method. Data in absolute dimension system always refer to a fixed reference point. Incremental dimension method. When using incremental dimension system, every measurement refers to a previously dimensioned position. Procedure for part programming. Study the relevant component drawing thoroughly. Identify the type of material to be machined. Determine the specifications and functions to be used. Decide the dimensions and mode, metric or inch. Decide the coordinate system, absolute or incremental. Identify the plane of cutting. Determine the cutting parameters for the job or tool combination. Decide the feed rate programming, mm per minute or mm per revolution. Check the tooling required. Establish the sequences of machining operation. Identify whether use of special feature like subroutines imaging. Decide the mode of sorting the part program once it is completed. Programming methods: computer-aided machining, CAM systems, computer-aided design, CAD systems. CAD or CAM systems allow for rapid development and modifying of designs and documentation. The 3D geometric model produced becomes a common element for engineering analysis (FEA), machining process planning including CNC part programming, documentation, quality control and so on. Structure of part programming. Part program. The number of blocks written sequentially form a part program for the processing of particular component. Block information. Meaningful command for the machine to execute. A block example is as shown. Sequence number N. Preparatory codes, that is G codes, to indicate the type of movement required, point to point, straight or circular, from one coordinate to another. Coordinate values X, Y, Z of the entire tool parts as suited to machine the complete component. Miscellaneous codes, that is M codes, for initiating machine tool functions like start, stop, spindle movement, coolant on or off and optional stop. Spindle speeds S, feeds F, tool numbers T. Preparatory codes, that is G codes. Preparatory codes are started from G00 to G99 codes. These G codes are generally used to movement from one coordinate to another. The following G codes are used to write the part program. Miscellaneous codes or M codes. Miscellaneous codes are used to initiating machine tool functions like start, stop, spindle moment, coolant on or off and optional stop. The following M codes are used to write the part program. Turning program. Students see the part drawing and other details for the turning operations like facing and plane turning operations using CNC turning machine. See the manual part program for turning operation. Milling program. Students see the part drawing and other details for the milling operations like straight and contouring operations using CNC milling machine. See the manual part program for milling operation. CNC machine tool. Sequence of operations are performing through CNC milling machine. For the sequence of CNC machining operations, upload the soft copy of the program or directly enter the program in CNC machine control panel. Mount the workpiece on the machine bed. Set the workpiece position on the CNC machine by using the needle dial gauge. Move the CNC table by jog mode and enter the reference values in the work coordinates G54. Load the 10 mm diameter end mill in the tool turret. Run the program in machine mode. After the machining, see the generated machined surface. Thank you.
At MSR UAS, we spark your imagination unlike any other.